So when we are planning for a offshore platform, we need to see the following points like a platform function and layout, how we are going to plan for our offshore structural design. So there are some few points like platform function layout, platform location, orientation of the platform. These all comes under planning of the offshore platforms. Water depths and tides, access and auxiliary systems, fire protection system, deck elevation, well placement and structural support, and equipment material layout, and then personal material handling, spillage and contamination management, exposure to extreme environmental conditions, integration and collaboration. All these 13 points, it's important when we are planning for a new offshore structural platforms. So we can see like review the preliminary primary function of the platform. So what's the function of the platform that we have to see? That's the first and foremost. What's the function of the platform, whether it's a drilling, production, storage, or etc., and discuss the ideal equipment layout. After that derives the ideal equipment layout. How will clearance and spacing for various systems? How will the clearance and spacing between the various systems like drilling, production, storage be planned to ensure operational efficiency and safety? The next one is that are there any specific constraints needed for combining multiple functions on a single platform? That also we need to look into it. And platform location, evaluate the geographic location of the platform site and how environmental conditions like waves, tides, wind will influence the design. Discuss how the local foundation conditions may vary and their impact on structural integrity. How do geographic and environmental conditions shape the selection of the oceanographic design parameters? And we need to see the orientation of the platform. We need to discuss the orientation of the platform based on the prevailing seas, winds and currents. And also how will the operational requirements, these are also important operational requirements, example production flow or crew access, affect the orientation choices. Is there a flexibility in orientation if the environmental conditions change over time? Suppose if the environmental conditions change over time, do we have any flexibility or not? That also we need to think about it. Like water depth and tides, assess the required water depth and how tidal changes will affect the platform elevation structural design. So these things are mainly important for when we are designing about the platform elevation structural design. Water depth and as well as tidal changes we need to consider. We need to assess how will the wave height and periods be factored into the design to avoid structural damage or failure. What are the implications for boat landings and fenders, deck placement at varying tidal elevations, because boat landings and other will vary based on the varying tidal elevations. Access and auxiliary systems. So discuss the placement of access points. Access points means like the stairways and boat landings for safety and ensuring at least 2 access points at each manned level. How can the access points be positioned to allow for easy evacuation during emergencies? That's the main thing. Like we need to make an easy evacuation during emergency. So we need to think about like how can access points be positioned. What other auxiliary systems are needed to ensure smooth operation of the platform? We need to ensure that the operations should be smooth. So we need to think about it like what are other auxiliary systems are needed. And fire protection system, review the fire protection system requirements based on the platform function and equipment. How will the system designed to meet federal, state and local regulations? Discuss any potential challenges in implementing fire safety measures on platforms with mixed use of functions, that is drilling and production. And deck elevation and design also we need to see it. How will the deck elevation be determined to withstand wave forces and provide adequate clearance for safety? Discuss how to ensure the deck is above the design maximum crust height and implications of air gap planning, and other provisions for local maximum crust elevations and exceeding the design values, and well placement and structural support. Discuss the integration of well conductors with platform design and how to account for environmental force acting on them. Integration of well conductors and what design elements are necessary to support the wells connector pipes, especially in regions with significant wave height. How will the platform design accommodate future wells and subsea completions? Equipment and material layout. Review the layout plans for heavy equipment, material handling, considering both immediate and future operational needs. So we need to consider both future operational needs as well as immediate needs. And how will platform framing be adapted to support heavy concentrated loads? Are there any provisions for future equipment upgrades or expansions? And personal and material handling. And discuss plans for personal material handling, including boat landings, cranes and helicopter facilities. How will the number, size and location of the cranes and landings be optimized for operational efficiency? Are there any logistical challenges related to the moving materials between the decks or getting them onto the platform? Spillage and contamination management. How will the platform address potential spillage or contamination? What measures will be taken under the meet regulatory requirements? Review the design drainage system for effective spill collection and storage. What steps will be taken to ensure environmental protection while handling spills? Exposure and extreme environmental conditions. Discuss the anticipated extreme environmental conditions and how the platform will mitigate risk. How will the systems and components be designed to handle worst case weather conditions? Are there any contingency plans for unexpected exposure to hazardous environmental conditions? Integration and collaboration. How will each engineering discipline collaborate to ensure a unified design approach? What are the biggest risks identified in early planning stage? How can they be mitigated collaboratively? How do we ensure ongoing updates and communication as the new data environmental operational conditions become unavailable? These are the points we need to think about it. Like, okay, this is a discussion about building engineers. All right, team, we got a lot to cover today. The platform design is getting closer to being finalized, but we need to dive into details. Let's start with the big picture. That's the functional layout. How do you ensure that our equipment and systems fit efficiently and safely on the decks? Any thoughts? We can't forget clearances and spacing. It's easy to get carried away with the overall design, but without careful planning, we will end up with a logistical nightmare. Equipment needs to be accessible, and we need to have to think about how each component interact with others. And too tight, we risk operational inefficiency. Too loose, we waste valuable deck space. How do we find a sweet spot? Exactly. And what about the future needs? If we design with only current requirements in mind, we are setting ourselves for failure down the road. You know how it goes. Once we start drilling, we will realize we need additional systems that we didn't anticipate. How are we accommodating in future operations? All good points, but here's the question: what happens if we end up in the environment with extreme conditions? We can't assume everything will always operate smoothly. I mean, we are looking at something serious wave forces here. How are we adjusting the deck elevation to make sure we are above those maximum crust heights? I'd rather overestimate than be underprepared. Alright, let's take on that. We are talking about water depth and tides next. What do we really need to know about the tidal variations and wave heights to ensure the wave height we have the right platform elevation? And remember, we can't ignore the location of the platform. Environmental conditions vary significantly by geography. I'm thinking about the foundation conditions, seismic activity, and the strength of the local tides. How are we integrating all of that? Don't forget about the orientation. We might be overthinking the foundation and water depth, and if we don't align with the platform with prevailing seas and winds, it could cause structural issues. Why aren't we factoring into that equation yet? You're right, the platform's orientation needs to be aligned with environmental forces, but what about access? We can't assume that one size fits all approach, right? I mean, two surveys to each manned level. What if one of them is blocked during emergency? Are we really meeting the safety requirements? We need to ensure that our auxiliary systems, boat landing stairs, cranes, and even helicopter pads are not only operational but also safe in extreme conditions. Does anyone have a solid plan for that? I think we are on the right track, but there's a whole fire protection issue. If something goes wrong, how do we contain it? How do we ensure that we are fully compliant with regulations, especially when there's a mix of equipment on board? And what about spills? And we can't just have a basic drainage system. The collection and handling of spills have to be foolproof. We need something capable of dealing with contamination without harming the environment. Shouldn't be that part of our safety measures. Speaking of safety, we need to keep an eye on how are we going to handle personal materials. I know we have already touched on cranes and boat landings, but we are not just moving equipment around. We have to think about the crew welfare. And what if the conditions are so bad that helicopters are on the only way in? Do we have provisions for that? Great insights, everyone. Now let's look back into the equipment and materials layout. We need to ensure that all the equipment is positioned with future needs in mind. Heavy equipment like drilling units and storage tanks needs a solid foundation. How are we planning for that, especially if we add more equipment in the future? Speaking of the foundations, what about well placements? We are going to need account for the exposed well conductors and the forces they will face. How early do we need to incorporate it into the design? And if there is a subsea well, how do we plan for the future extensions? Don't even get me started on the exposure to extreme conditions. If a massive storm hits, we need to ensure that platform can handle it. I'm talking about everything from structural integrity to equipment survival. Are we doing enough to prepare for the worst? That's exactly the question. Are we truly ready for the extremes? It's a balancing act, being prepared for the worst without over engineering to the point of unnecessary cost. I think we covered the most of the critical elements here, but we need to go through each point with a fine-tooth comb. Let's prioritize the most urgent issues: orientation, safety, access, structure, and then we can address everything else. We got a solid foundation for the comprehensive design. I agree. But let's also factor in flexibility as we move forward. We'll need to be adaptable. One small change in the environmental conditions could throw everything off. Let's build that adaptability into the design, right? Alright. Let's make sure we are thorough. but not so rigid we can adjust when unexpected happens. First, we need to see the function and layout also. How are we going to fit everything on the platform? Is there enough space between the equipment? What's the plan? We can't just cram everything in. We need clear paths, easy access to equipment, and enough room to work. If it's too tight, we are in trouble. Too much space, we are waste valuable text area. So where do we draw the line? And we can't just think about what we need now and what about the future needs. What happens? We need more equipment down the line. If we don't plan for that now, we might be in trouble later. How do we keep things flexible? And we are forgetting something. What about the extreme weather? If you don't plan for those, we'll cut off guard. How high do we set the platform? I will prefer for the worst case wave height. Let's dig into that. We need to know what are the tides for accurate platform height. How do we make sure the platform stays above the highest wave? And don't forget the location also. Each place has different conditions. We need to understand how environment will affect everything. The foundation, tides, weather, it all matters. Are we factoring all of that? The orientation, where do we place the platform? If we don't align it properly with the winds and waves, we could be asking for trouble. We can't ignore that. We need to also think about the access. How do we get the platform? How do we get to the platform safely? What if one of the escape routes is blocked? Can we evacuate quickly if something goes wrong? We need boat landing, stairs, cranes, but also we need to think about the fire protection. If there's a fire, how do we control it? How do we make sure the system follows all safety rules? What about this personal material handling also? Do we have enough boats, cranes, and space for everyone to do their jobs? What if we need helicopters? Are we ready for that? We should make sure that we have space and systems in place for that possibility. Okay, this is about the layout. What is it? I'll give you more about it. Now we get into the one big one, like equipment material layouts. Where do we put the heavy stuff? Drilling units, storage tanks. How do we make sure that they are positioned correctly and supported in long term? Also, we need to consider the welds. If you are dealing with exposed weld conductors, we need to know exactly where to place them. How will the platform handle the forces from those? And extreme exposure. What happens if we get hit with a storm that exceeds our expectations? We need a platform that can survive the worst conditions. How are we preparing for that? The real question is, are we really ready? We need a platform that's a solid, can handle anything thrown its way. Are we thinking for enough Earth? Let's break this down. We will tackle each point: access, fire protection, layout, one step at a time. We will reconvene pause and see where we stand. Let's keep the pressure on. We need this platform to be ready for anything.